So in this problem, it is given here that a circle passes through the origin and it cuts off an intercepts of A and B from the x and the y axis. We need to determine the equation of this particular circle. So let us begin. First, we'll try to understand the problem graphically. So here we have the Cartesian plane with the x and the y axis. We have the circle that passes through the origin and it cuts off an intercept of A on the x-axis and it cuts off an intercept of B on the y-axis. Now, the point where it has an x-intercept of A, we're going to consider that point as A comma 0, and the point where it has an y-intercept of B, that point B 0 comma B. We need to find out the equation of a circle. So we're going to use the diameter form of a circle. So let us assume, for the time being, we're not sure yet, we'll assume that AB is the diameter of the circle and it passes through the center. This is an assumption, but we'll have to be sure, 100% sure that it is indeed the diameter of the circle. Now, if it were the diameter of the circle, and then definitely C must be the midpoint, then we can use the endpoints to find out the coordinate of C. So we have 0 plus A, so that's going to be 0 plus A over 2, and then the coordinate, y coordinate will be B plus 0 over 2. This means that the coordinate of center C must be A over 2, comma B over 2. So here we have obtained this coordinate by using the midpoint formula. Now, let's confirm that this is indeed the coordinate A over 2, comma B over 2. What we'll do, we'll drop a perpendicular from the center to the chord OA. So let's call that point D. So here, OD is going to be DA. That's because a perpendicular drawn from the center of a circle to any chord always bisects the chord. So that means, since the length of OA is A units, the length of OD is going to be A over 2 units. Similarly, we can drop a perpendicular from the center. Then this is going to be point E, and CE is going to also bisect the chord OB. So that means length of OB is B units, so length of OE is going to be B over 2. Since the length of OE is B over 2, so length of CD is also going to be B over 2. So that means the coordinate of the center is going to be A over 2, comma B over 2. So that means AB is the diameter of a circle. Now that we have the diameter of a circle, we can use the form x minus x1 times x minus x2 plus y minus y1 times y minus y2. So this is going to be the equation of a circle. We know this. And in this equation, then x1 comma y1, that's going to be represented by the point A comma 0, and then we have x2 comma y2, so that's going to be represented by the point 0 comma B, which means x1 value is A, y1 value is 0, and we have x2 equals to 0 and y2 equals to B. Now we can substitute this back into our equation. So we have x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals to 0. Now on expanding, we get x squared minus ax plus y squared minus by equals to 0. What? We have x squared plus y squared minus ax minus by equals to 0. So this is the equation of our circle. Now the question is this the only circle that's possible? No. We could, here in this particular example, we have considered that the x-intercept is positive as well as the y-intercept is positive. We could have the other case where the x-intercept is negative and the y-intercept is positive. So that means this is going to be the other circle, and then we are also going to have a circle which has both x and y-intercept negative, and the fourth scenario could be where the x-intercept is positive but the y-intercept is negative. So in fact, there are a total of 4 circles that are possible. In that case, the equation would be x squared plus y squared plus ax plus by equals to 0. Other case would be x squared plus y squared minus ax plus by equals to 0. And we have the fourth possibility, x squared plus y squared plus ax minus by equals to 0. So in fact, there are 4 circles that are possible. Now I'm leaving that as an exercise for you to try out to confirm that these are indeed the 3 equations, and this is how we can obtain the equation of a circle with the given criterion.